An example 4 says find the value of y in triangle RST above. Remember we found x before, and x in example 3 was 4 square root of 5. And if I look at this, I can just go ahead and I can take x, y, and then the hypotenuse, and it's a right triangle, and I can just use the Pythagorean theorem. Now, there's another way that I could do this by using equal parts and all, but we'll just use the Pythagorean theorem on this. So I got a squared plus b squared is equal to c squared. So then this is going to be 16. Why am I doing that? I can just take the entire hypotenuse as being 20, and my legs is x and y. So I'm going to have 4 square root of 5. So one of my legs is squared plus y squared is equal to 20 squared. So 4 squared is 16. Square root of 5 squared is 5 plus y squared is equal to 20 squared is going to be 400. And 16 times 5 is going to be 80. So I'm going to get 80 plus y squared is equal to 400. So I'm going to subtract 80 from both sides. So 400 minus 80, that is 320. I'm going to move over so I have a little more room. So y squared is equal to 320. So I take the square roots of both, and I got y is equal to the square root of 320. Remember, again, typically when we take a square root, it's plus or minus. However, when we're talking distance, we know it's just going to be positive. I can look for perfect squares in 320. And so a perfect square in 320 is actually 64. So I'm going to say y is equal to the square root of 64 times 5 will mean y is equal to 8 square root of 6, or 8 square root of 5 is the value for y.